There's a huge and increasing number of open source components available. This is the aggregate number of components available in NuGet, NPM, Ruby Gems, and 15 or so other lesser package managers. This comes from a website called Module Count, so there is some duplicate here, but you can see the number is close to 2 million. And it's increasing pretty linearly. There's an increasing number of vulnerabilities out there. So in 2018, there were 16,000 and change. Those are just the ones with CVEs. Most vulnerabilities don't get CVEs. So if you have a GitHub repository and someone just says, oh, I found a cross-site scripting thing in your thing, I say, got it, fixed, PR, done, merged, new version. There's no CVE for that. There's also an increase in complexity. So when an engineer pulls in a component, they're not just pulling in that one component, they're pulling in everything that component depends on, and so on down the line. I love this graph. Nice! Did I kill it? Did I break it? I guarantee this was an amazing graph. I'll describe it to you. It's this wonderful universe cloud thing that shows the dependencies between NPM modules, and it's the entire NPM universe, and all you can see is it's just an amazing thing. So I'm sorry I can't show it. I can't show the next one either. Okay, how are we doing there? No. Okay, cool. So. The next slide that I can't show was showing Mocha, the NPM component Mocha. When you bring in Mocha, you bring in 175 in its full dependency graph. Those are authored by over 100 different contributors. The developer just sees Mocha. They just think Mocha. When you're saying, how many components are you using? They're going to say one, just Mocha. And it's not their fault, because package managers make it really easy to just add a component. At the end of the day, your company, your org, your team, you're responsible for everything that you ship. Everything. Because an attacker really doesn't care who wrote the vulnerability, and neither will your customers. So I'm here to talk about how Microsoft has built an open source security program, some of the things that we've learned. In particular, it's about our use of open source. We also are a publisher of open source. I'm not really going to talk about that too much. So we made it really simple. We have 4 steps, 4 things that we need to do to effectively manage this. First, we need to know what open source we're using. This is a surprisingly difficult thing to achieve. We need to centrally catalog it, because once you have all this information, why not throw it in a database that you can query? We need to make sure that it's secure, actually secure, not pretend secure. And when it's not, we need to respond to security vulnerabilities in a way that makes sense for the org and everything. So, first one, identifying open source. This is the creation of a bill of materials. There were commercial tools to do this. There were open source ones. A lot of organizations have built their own. When you use package managers, it makes this job pretty easy, but not every component comes from a package manager. Who knows developers that just copy a thing into a /source/external directory? So those are very often, it's more difficult to pick those things up. Or if you just take a snippet from a gist or a Stack Overflow comment and just copy it in. At some point, it becomes your code. But the larger the code that comes in, the more you may want to be able to identify that as open source. So when a vulnerability affects the larger thing, you can see if you're affected. So the takeaway that we've learned from this is organizations usually fall into 1 or 2 camps. It's to manually attest, have every development team fill out a form that says, what am I using jQuery, what version, and submit it off. That will pick up Mocha sometimes, if they remember, and it's not too hard, and they don't have a deadline, and things like that. This has to be automated. It has to be automatic. It has to come from the fabric of the engineering system. Whatever engineering system you use, it has to just come for free. Developers shouldn't shouldn't have to do anything special for this. When Microsoft switched from a manually attested thing to an automated thing, no joke, like 10,000 times more open source was found when we did this. So the discovery itself is actually pretty simple. You have your program source code, you've got artifacts, you've got binaries, whatever it is. It goes into a bucket. The discovery tool looks at the bucket and says, oh, I see you're using jQuery this version and zlib this version, and pulls that stuff out. Creates a bill of materials. Great. Then we throw it in a database. Database has to include where you found it. What this really gets you, the best thing here is, how long were we vulnerable to this thing? Which components? Who do we have to go after? If you can turn the picking up the phone and calling your dev managers exercise into a query, or even better, throw that automatically out to the dev managers, you win. Okay, so now we know what open source we're using, but we don't know if it's secure or not. So every organization can learn about security vulnerabilities in multiple ways. You can just look at the news and wait for a website with a logo to come up. You could check for public CVEs, and that's good and necessary, frankly. You could even include some commercial databases and vendors that go out and specialize in this, whether it's curating the CVE database or adding their own on top of that. But then you kind of go up into the higher cost but higher return category. Who thinks that, all open source, so I said there are about 2 million open source projects out there. How many of them have had someone actually look at it from a security perspective? Probably just the very, very tip. So if you're using something, especially something that depends on something way down the graph, chances are no one's ever looked at that. And a vulnerability in that thing all the way down there could affect your final widget just the same. So the way that we look at it is every open source component that we use, we need to be able to gather the first 4. But there's a special category of high-risk components, OpenSSL, things that make authorization decisions, crypto libraries in general. These are things that a vulnerability there could have a much deeper impact on your thing than others. So if everyone has limited security dollars, we prioritize those. So what this really means is doing in-depth security reviews. So part of what my team does is go off and proactively assess open source components, not within the context of how's it being used, because we're expecting there to be 1,000 uses of OpenSSL or zlib or things like that, but instead, can this be safely used in any reasonable context? So what does this really mean? We look at things like project health. We will do a code review depending on the size of the component. We're not going to do a full code review of OpenSSL. It's just not feasible. We look at things like secure configuration, like when you deploy Elasticsearch, should you have that exposed to the internet? When we come up with advice there, we throw this all into effectively a report. We'll include, obviously, public vulnerabilities make their way into this, but then we do static analysis on everything, and it's high quality static analysis, so you're not wading through 50,000 false positives to find the one gem. We've kind of tuned it to just find the things we're really looking for. So we have a dedicated team doing this for Microsoft. We have a system that we kind of throw this stuff into. And so component health, we score it on a bunch of different areas. We look for things like typo squatted packages. So this is the NPM left pad. There's also a left sad, a left pad without the dash, a left underscore pad, because we needed that too, and a reft pad. Some of these were accidentally, oh, I just created the package too fast and I made a typo. Some of the other ones, I'm not so sure. We look at things like maintainers. So although you can't see the lines on that, the red dot in the middle is left pad itself. The blue ones are connected to the red, and those are the maintainers. And the yellow ones are other packages that those maintainers have contributed to. So this is an emerging idea that we're looking at to see, can we infer software quality through what a maintainer graph looks like? Is there a healthy maintainer graph? Is there an unhealthy maintainer graph? So once we flag it flag a component as vulnerable or dangerous, or we use the phrase use discouraged because we don't have the context. If you're not exploitable, you have to make the decision yourself, but we can give you the best advice we can without that context. So we include, once we flag a component as bad, that goes into a stream, and the stream is combined with up-to-date public vulnerability data, CVEs, curated stuff, static analysis results, and engineers are automatically notified. This is the key piece that makes this all work. So an engineer comes in on Monday morning, includes a component. Tuesday, we get around to reviewing that component. We take a look, we say no good. Probably Wednesday morning, they'll get a work item that says, you effectively don't use this component. What we usually say is upgrade to the latest stable. But by far, that's the most common scenario. But we do find new vulnerabilities too. And when we do, we work with MSRC, with our response center to get those out back to the authors, to get them fixed. We strongly discourage internal forking because those forks tend to live forever. But there's a key difference in managing response process around open source, and that's because we don't really have, it's different than managing response on an internal team. You don't know who the authors are. You don't know if you're actually talking to the author, or if the author had his credentials compromised and you're talking to, quote, the bad guy. So it's nuanced, and it's a bit harder and different. So we've talked about these four. There's a couple other things that you should be thinking about, though. First, building from source. So when you include open source, you can include it as source. There are also lots of package managers that will just give you a binary, like NuGet. You have no assurance that the binary matches the source. For that matter, a lot of package managers aren't really reflecting the source either. They're reflecting a tar file that someone uploaded. But the binary, it's very difficult to analyze a binary to say, what is this thing really doing? When you include open source, are you pulling it from the internet? Is your CI system just wired up to NuGet.org or NPM or RubyGems? If so, like how quickly, you could kind of turn this model on its head and say, how quickly could a vulnerability be introduced in a thing, in an open source component, and have CI systems pick it up and deploy it out to customers? Because the rest of the development world wants to minimize that time. And if you're pulling from, if you're configured to, use latest, that could be very dangerous. We talked about typo squatting a little bit. Freshness. So, as I said, usually we tell people to just upgrade to the latest stable. And we got to thinking, what if we just didn't have to do the whole vulnerability thing and just tell people to upgrade to the latest stable, since that's the usual advice? We're not really going to go that far, but we are pushing a more of an engineering hygiene position of keep your open source components up to date. They don't need to be immediately up to date, but they shouldn't be taken and then used forever until someone comes and tells them not to. And the important thing here is this is when there are no vulnerabilities. Obviously, if there's a vulnerability, you have to do something about it. But if you have a component out there that is just, it's abandoned, it's not maintained, sometimes it's because the component is complete and there's nothing left to add to left pad. But often, you wind up getting a lot of security value from just upgrading. Analyzing high-risk components is easy to say, oh, this is a high-risk component. And usually when you look at it, you can do it. How do you do that at scale? So looking for ways to identify from a very large set of open source components, which ones should you be looking at yourself? And then tying this all together into a kind of a coherent program management around open source. How, are you managing this out of a compliance group? Is this managed out of an engineering team? Is this the CISO office? Are they looking at open source as a thing in and of itself, or is it considered a third-party supplier kind of domain? There are lots of ways to get to goodness here, but being deliberate about it, I think, has a lot of advantages. So last summer, there was a backdoor thrown into Eslint-scope. I think probably, who here is familiar with the Eslint-scope story? Okay, so the author had his credentials popped. Bad guys went in, threw a different version of it out there, and that was really bad. So we got to thinking, like, are there any more out there? Maybe this wasn't the only thing that was popped. And we were a little bit more real, and we said, how many more are there out there? With so many packages out there, they can't all be clean. So we did an experiment. We looked for, we built a static analysis rule that could detect ESLint, or parts of the Eslint-scope backdoor. And we ran it across a sample of NPM projects just to see what we would see. Basically what this did was it looked for data coming from an untrusted user, flowing into the app, and then basically be concatenated and then piping to command.exec. So I ran this against 50,000 completely randomly sampled components. Found 14 vulnerabilities. Triaged them all. They were all real. Working with MSRC, getting the authors notified and fixed and all of that. There's a really good takeaway here, though, and that is that none of these appeared to be malicious. The difference between a backdoor and a vulnerability is kind of intent. I can't really infer intent from static analysis too well. So these look like just sloppy, accidental, normal run-of-the-mill vulnerability, but they were absolutely remote code execution from a GET or a POST request. So we think that this approach has legs, that looking for, being able to scan an entire ecosystem for a very tightly defined class of vulnerability has a lot of, it has legs. So some key takeaways. First, you have to have an accurate inventory of the open source that you use. If you're looking for developers to manually attest, you're getting a very, very low response there. You have to automate this stuff. Use high quality data sources. CVEs are good, but don't stop at CVEs. Leverage your existing incident management processes to do this stuff. Don't try to invent your own custom open source response thing. Leverage the larger system if you have one. When talking to developers, a question that I get pretty often is, how do I know if I'm vulnerable to this? And the answer is usually just upgrade. The time that you spend determining if you are vulnerable to this, for this vulnerability, may have to be repeated for the next vulnerability and the next one, and eventually you can upgrade anyway, so just upgrade. Sometimes that's just not feasible, and usually that's because, I'm using this version from 9 years ago, and everything has changed, and so life can be difficult. Keep a closer eye on the high-risk open source that you're using. The way that we created a graph of the relative risk of different open source components, and it always looks the same. We tried different algorithms, and it's always this super high risk stuff all the way up here, and then a really, really long tail of low risk stuff that doesn't matter very much. Have a way of doing that within your organization. Certainly keep up to date. If there was one thing that if I had a magic wand and I could have developers just do one thing, it would be to have a process of keeping yourself up to date. And then just try to stay on top of this. There's always new package managers coming out and ways to include things, and just the industry itself is moving so quickly. to have a, even a small team thinking about what's coming next lets you get there before you're in hot water. So a lot of people think about open source as it's free like in beer, it's free like in whatever. It's not, it's free like a free puppy. So that's my close. So do you plan on open sourcing your open source package evaluation tool? I would so I'm a big proponent of open sourcing this stuff. A lot of things are not, like, there's very little Microsoft specific stuff in there. I would love to. That tool actually we just released it, well, we just made it available internally a few weeks ago. So we're gonna give it a little bit of time to mature, but I would love to not have all of us be reinventing the same tooling that's kind of commodity. And the scariness of open source, is the scariness of open source really about open source or just about dependencies, whether open source or not? I think open source is a little bit different in that regard than traditional dependencies. A third-party dependency like a commercial vendor, you have kind of a neck to choke that has an incentive to kind of keep you happy in some way. Whereas the open source community, you're relying on goodwill, you're relying on people who, by and large, you've never met, and whose their commitment to the project kind of depends greatly on what type of project it is. So there are certainly some open source projects that are stellar and amazing in how they kind of treat their customers and kind of adapt and all that. And then there are a lot of single person. This was a hobby project, a thing that I published a year ago, and I have no desire to kind of maintain this. Absolutely. What's your criteria to identify high-risk OSS? So I could sprinkle some machine learning magic on things, but effectively what we did was we took certain things that we just felt made it high risk, like if it has the word crypto in the name or things like that. It's effectively a weighted average of a bunch of different things. And then when we ran it, we kind of tuned it until the things that we knew were high risk were kind of at the top anyway. It's not super academic, but it was good enough for what we needed it for. When using third-party commercial components, do you apply the same processes to those as OSS? No. So third-party commercial components, because we don't usually have the source code, we can tell the vendor, attest to us that you have followed the SDL or you have a coherent security management program and you're following it and things like that. We do usually have get the right to audit source code and pen test and things like that, but it is run more out of a procurement area. And the tracking system that we use, so you saw the tracking system that we're using. We have a back-end Azure DevOps, just work item tracking thing for our own internal work, but that's not very interesting. We have a separate system for tracking open source usage. So what the developers see is, they get a list of here's all the open source that you're using, and this is good, 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 bad, bad, bad. That's an internal system that we have, that a different team at Microsoft has built for us. I think that's it. Thank you very much.